Welcome to the Hard Surface Advanced class. Today, we are tackling one of the most critical aspects of hard surface modeling, bringing a real mechanical feel to your designs. I'll show you how to make your model look like they're beyond in a high-end sci-fi universe or an industrial-grade machine. We are breaking down the 60-40 rule, how to find the perfect balance between simplicity and complexity, and how to place details with precision, not just randomly throwing in panels and bend. I've spent countless hours studying, testing, and perfecting these methods. So, this isn't theory, this is what works. If you want to be more than just another 3D artist, if you want to design with intent, confidence, and control, then stay with me till the end. This is next level hot surface modeling. Let's get started. First, let's understand about the foundation of modeling. Understanding the shape. Everything starts with a shape, no matter what you're modeling. Whether it's a spaceship, a mech, or any sci-fi structure, it all begins with a base shape. But identifying that shape can be tricky, especially when working from a complex reference. Here's how to simplify it. Take this spaceship reference. At first, it looks overwhelming, too many details, angles, and forms competing for attention. But instead of focusing on the complexity, just trace the base outline. Once you stripe it down to its core shape, everything clicks. Think of it like creating a bold stroke around your reference. Once you have that, you are ready to build in 3D. Now it's time to decide on your approach. You can go with a subdue workflow for smooth controlled surface or a Boolean based workflow for sharp industrial form. The method doesn't matter, the foundation does. And this is how you build it right. Here's how I model the block code for my spaceship project. I start with a simple cube, scale it up, and extend it along the x-axis to get the general shape. Once I have the base dimensions, I activate box cutter to start carving out the form based on the outline I created earlier. I select the n-gon cutter and make my first slash at this angle. Next, I move to the left side, use a symmetrical cut, match the shape, bring it down, and cut it. Now press Q and smart apply. I manually bevel the sharp edges. I select these two edges and run a bevel. Looks good. But the front portion looks too large. So let's cut it down. That's better, more balanced. Back to beveling. Select this edge, bevel. Go to the back, select this one and bevel. Then this one, bevel again. At this point, the side view is smooth and curved. But the front is still sharp and hard. To fix this, I Alt plus left click to select all edges and run a bevel, same for the back. Now, in my case, I cut the top portion a bit too much, leaving a space for beveling. But that's fine, this is just to show the process. Anyway, the thickness looks a bit heavy, so let's scale it down on the y-axis. Now just mirror to the other side, adding the circular cutout. In the reference, there is a huge circular cut in the center. Let's make it. Super simple. Just add a cylinder, flip it, and scale it up. Adjust the position until it sits right. Then, select both the shape and cylinder, run a difference boolean, and smart apply. To clean it up, I'll use box cutter to remove the remaining shapes, smart apply again, duplicate the model, move it down, and mirror it to the z-axis. That's it. The blockout is done. Next, let's talk about one of the most important principles in hard surface modeling, the 60-40 rule. This rule is all about balancing detailing and empty space to make your model look clean, structured, and visually appealing. What is 60-40 rule? It's simple. 60% of your model should have empty space, clean, smooth surface. 40% of your model should contain detailing, hard edges, vents, wires, and mechanical elements. When you follow this principle, you create a perfect balance between simplicity and complexity. The hard, mechanical parts grab attention first, while the clean area gives the eye space to breathe. Why does this work? Let's take an example. Look at these two images of arrows. Which one catches your attention? Obviously, the left one. But why? What's wrong with the second image? The answer is lack of separation. The second image is overcrowded with details, so nothing to stand out. But in the left image, the green leaves create an empty space, make the red rose pop. The same concept applies to hot surface model. Now, let me show you how I implemented this rule in a spaceship model. Take a look at the machine gun on the top and bottom. If we break them down, they're just a cube, a cylinder, and some boolean cuts. But what makes them stand out is how they are placed. I used symmetrical cuts and stacked additional meshes on top. I keep the surrounding area clean, make the mechanical part look complex and intentional. I added a flat sci-fi cable which I covered in my Break the Limit series. If you are struggling with making the sci-fi cables, definitely check that out. These shapes aren't complicated, but they look complex. Here's my tips to achieve a sci-fi mechanical feel. If you want to make your hot surface model stand out, here's what you need to do. First, gather reference. Always. If you don't, you end up with a sloppy model. Next, increase mesh density. Add cylinders, cubes, and layers of small details. Cut deep. Use boolean, slice, and engravings. Highlight edges. A simple chamfer can add realism and depth. Like a boolean, a chamfer can highlight the edges and separation, which will really enhance the realism. Follow this principle and you'll create stunning mechanical parts that actually feel functional. Now, let me show you how I model this cylinder shape. It's super simple. Start by adding a cylinder, scale it along the z-axis to make it thinner, then extend the size to get the proportion right. Next, let's add some detail. Chamfer the top and bottom face for a softer transition. Insert the face and extrude it inward. Then scale it down. Repeat insert, extrude, scale process one more time. Refine the shape. Finally, extrude it all the way up. Add a loop cut, scale it down slightly, and run a bevel to achieve that nice curved loop. And that's it. Simple but effective. Now, let's talk about slicing and deep cuts. Two powerful techniques that add instant mechanical depth to your model. Slicing. A small panel separation can turn a flat surface into multiple functional parts. Make the design feel more structured. Deep cuts. Carving into the model, add layers, shadows, and depth, giving it an industrial high-tech feel. Here's how you can achieve it. Choose the right spot for your cut, preferably along symmetrical areas to keep the design balanced. Run a cutter along the surface. Bevel the cut to match the shape. Press X for the slice operation and cut it. Scale the piece slightly to highlight the separation and make it pop. Simple, effective, and make a huge difference. This technique is a game changer. It's something most people overlook, but it's what truly brings the instant and sci-fi vibes to your model. Let's break down. One of the best way to make your model feel truly mechanical is to expose its internal components. I call this the open window technique. What is open window technique? Instead of keeping a surface solid and closed, you cut open select areas and add some cables, pistons, vents, and machinery parts. This instantly makes your model feel like a real working mechanism instead of just an empty shell. Why does this work? It adds layers and depth, make the design more visually complex. It exposes functional parts, giving the impression that your model has real mechanical underneath. It creates contrast between solid area and detailed section, which guides the viewer eye and makes the model more engaging. Here's how you can use it effectively. Choose the right spot. Look for area where machinery exposed makes sense, like joints, vents, or engine bay. Make a controlled cut. Use box cutter or booleans to create a clean, symmetrical opening. Fill it with a detail. Add cable, pistons, any mechanical part to bring the space to life. Balance is key. Too many open areas weakening the structure. Master this technique and your model will instantly feel more functional, complex, and sci-fi ready. And that wraps up this lesson. Let's do a quick recap. We start with understanding the shape because every great model begins with a solid foundation. Then, we explore the 60-40 rule, learning how to balance empty space and details for a clean mechanical look. Next, we use slice and deep cuts to add depth and structure. And finally, we unlock the power of open windows, revealing the internal mechanism for next level sci-fi feel. What to keep in mind? Placement matters. Random detail won't work. Intentional design will. Balance is key. Don't overly complicate it, but don't make it too simple either. Small changes create big impact. It's all about the right techniques. Always use reference. It gives you clarity, direction, and better design choices. Now, it's your turn. Take these principles, apply them to your models, and push your design beyond the limits. Thanks for watching, and as always, keep creating, keep innovating, and I'll see you in the next one.